Good afternoon. I welcome you to the session of IC engine and gas turbine, and today we will be discussing about the cylinder arrangement. As such, we have seen that the engine can be classified based on the types of combustion and the number of strokes used to execute the total process, and today we will see that we also can classify engine based on the cylinder arrangements. And before we go to discuss about the classification of engines, which is based on the cylinder arrangements, rather types of the cylinder used, just today we will try to see that why the cylinder piston arrangement is important, and rather why the different shapes of the cylinder piston arrangement is important to execute the different processes that we have studied in the last lecture. So, we will discuss about that the engine classification, and that in the last lecture we have discussed that engine classification is one is that based on the number of strokes, and another is types of combustion. This number of strokes again can be divided into two subcategories. One is 4-stroke engine, and another is 2-stroke engine. In fact, we have discussed, rather we have identified 4 different strokes which are important, which are required to execute different processes in a cylinder during, rather starting from intake to the exhaust. Now, we have also seen that for the 2-stroke engine there will be only 2 strokes, and we also have identified 2 different strokes, and just by these 2 different strokes all the processes which are there even for the 4-stroke engine can be executed, and the details of the strokes we have discussed in the last lecture. As we have discussed that engine can be classified based on the types of combustion, and based on this criterion we have divided engine into 2 categories. One is spark ignition engine, that is SI, another is compression ignition engine CI. And we have also discussed that what is the, rather what are the fundamental differences between SI and CI engines. We have seen that in a 4-stroke engine there will be true revolution of the crank per cycle, while for the 2-stroke engines we have 1 revolution of crank per cycle. So, this part we have discussed in detail, and today we will see another classification that we can have, that is based on the cylinder arrangements. But before we go to discuss that aspect, just we will try to recall that in a 4-stroke engine or 2-stroke engine, we will have intake stroke, then compression, then we will have power stroke, and finally all the combustion products should be expelled out from the engine cylinder. So, whether all these processes will be executed through 4 different strokes, or all these processes can be executed only by 2 strokes. Based on that, we have divided engine into 2-stroke and 4-stroke categories, but just we will try to recall today what we have learned from our undergraduate thermodynamics. So, now if we talk about heat engine, we have studied that a heat engine is a thermodynamic device which will operate between 2 thermal reservoir, temperature thermal reservoir, and one is higher and another is lower. This higher and lower, that means the higher temperature thermal reservoir from where heat will be supplied to the engine, and the low temperature thermal reservoir, that means the heat will be rejected to the that reservoir from the engine. That means this high temperature and low temperature, these two are defined. The higher means this is higher as compared to the thermodynamic state of the working substance of the engine, working fluid of the engine. Now, if the process is like this, that means TH is higher temperature thermal reservoir, that is TH higher than, the TH will be always higher than the temperature of the working fluid of the engine, and TL will be always lower than the temperature of the working fluid of the engine. Now, if the engine is drawing QH amount of heat from the higher temperature thermal reservoir and rejecting QL amount of heat to the lower temperature thermal reservoir, where both the thermal reservoirs are maintained at constant temperature TH and TL, and if we consider that the heat, rather the work produced by the engine is W net, then W net is QH minus QL, and the thermal efficiency of the engine can be written that W net by QH, that is the heat which is supplied. So, the heat which is being supplied to the engine is QH, and out of this heat we are getting W net amount of work, and this W net is nothing but the QH minus QL. So, I can write only W. Now, W net will be QH minus QL. So, this is QH minus QL by QH. So, this is 1 minus QL by QH. This is the expression of the thermal efficiency. We have also studied that if the processes, that is heat supply to the cylinder engine and heat rejection from the engine to the low temperature thermal reservoir are reversible process, that means for the reversible process, processes which is valid only for the Carnot engine, that we have studied in a greater detail in our undergraduate thermodynamic course. So, for the reversible processes, this thermal efficiency can be written 1 minus TL by TH, which is valid for the Carnot engine. Now, so from this, at least we can see that this device which is heat engine, if this device is connected between 2 temperature thermal reservoirs, then we can have a continuous work output from the engine. So, similar concept if we try to apply, we will see as such. I can tell now that we have seen from the engine nomenclature that internal combustion engine, we have one cylinder, piston which is connected to the crank, which is connected to the crank and connecting rod, and this the reciprocating motion of the piston is converted to this crank connecting rod mechanism to the rotary one, and from which we can drive wheel and we get movement, rather output. That is what we need to drive the different vehicles. Now, this engine cylinder movement, rather piston movement within the engine cylinder, that means the piston is moving, rather piston movement is restricted between 2 points, that we have also seen in our last lecture, that the top dead center and the bottom dead center. So, the reciprocating motion will be converted by the crank and connecting rod one, and we can run different either small vehicle and big vehicle. Now, the idea is, so somehow if we have if we go to the next slide, somehow if we have a kind of piston cylinder arrangement. So, say this is a piston cylinder arrangement, and this piston, this is gas. So, piston cylinder, so this piston and is in the cylinder, and the cylinder is having, rather cylinder contains gas, and the gas is in this condition, that means the piston weight will be there, say this is W piston weight. So, if I now try to connect this piston cylinder arrangement which is having gas with one thermal temperature reservoir, where the temperature of the reservoir is TH. So, if the gas temperature of the gas in the cylinder is say TR, and we are now connecting this entire arrangement with one thermal reservoir, where the thermal reservoir is maintained at constant temperature TH, where TH is greater than TR. Then what will happen? So, if I now allow heat to flow from this higher temperature thermal reservoir to the engine cylinder, of course, heat will flow because of the temperature difference, as TH is greater than TR. Now, the gas will try to expand. So, because of this expansion of the gas, so the thermodynamic state of the gas will be changed, and the piston will be raised by a height, say say h. So, now if we when this cylinder arrangement is connected with the high temperature thermal reservoir, rather high temperature thermal reservoir I can say now, and upon receiving heat from this thermal reservoir, the gas will expand, and because of this expansion there will be movement of the piston towards the outer side, and if we consider the movement is raise of the piston will be raised by a height h. Now, this is kind of a one way movement, but we have seen that in an internal combustion engine the piston movement is continuous, and movement is restricted between 2 points TDC and BDC. So, now what we can do, if we now connect the same thing with a lower temperature thermal reservoir, so the same arrangement is now connected with another temperature thermal reservoir TL, and if this TL is less than TR, then what will happen? So, after receiving heat from this high temperature thermal reservoir, gas temperature will be higher, there will be and there will be a process, that is the expansion process, and because of this expansion there will be movement of the piston, and if we consider the piston is raised because of this process by a height h. Now, what we are doing now, we are connecting the system with another thermal reservoir TL, where TL is less than TR, or TL is less than the temperature of the gas at that moment. So, now our objective is to bring back the piston in its original position. So, connecting this arrangement with this reservoir, that means now this TR is definitely higher than the previous TR, because this TR is now, of course, it has received heat from the system, gas has received heat from the high temperature thermal reservoir, and this TR now is higher than the TL, rather we need to design in such a way that the temperature of the low temperature thermal reservoir will be less than this TR, and heat will flow from now engine cylinder, rather heat will now flow from the gas to the low temperature thermal reservoir. So, now this QL and this QH. So, upon extracting heat from the gas, we can bring back the piston in its original position. So, this entire system is now as if we are now raising the piston from its initial position to the new one, and again by extracting heat from the gas we are bringing the piston back in its original position. So, that means as if we will have a reciprocating motion of the piston. If we connect this reciprocating motion with the crank and connecting rod, that we will get the rotary motion. So, that is the concept of internal combustion engine that we have seen. Now, question is, this is not a physically feasible situation, because this needs construction of huge thermal reservoir and that control of the movement of the piston from between these 2 points. It will be difficult if we try to design following this geometrical structure, but the idea is, that means we have seen that in an internal combustion engine we need to ensure that there will be a reciprocating motion of the piston cylinder of the piston in the cylinder, and the reciprocating motion will be converted into the rotary one. So, now to have this reciprocating motion, we need to ensure that there will be a working fluid. So, working fluid will be heated off, that will try to expand, and because of this expansion, so whether we will get movement of the we will get the movement of the piston. Again, if we try to reduce the temperature of the gas by drawing heat, so this is the concept of the that we have discussed just now, but the idea is that there will be expansion of the working substance of the engine, working substance of the fluid, rather working substance of the I can say internal combustion engine. That is what we have discussed, that the fuel air mixture, and that and there will be again the kind of I can say the removal of heat from the engine cylinder, from the working substance of the engine cylinder, so that I can bring back the piston in its original position. But the example that we have discussed now, this is not the feasible solution, this is not practically possible solution, because this needs a construction of huge thermal reservoir. So, but the concept can be used to design different engine cylinder arrangement, so that the combustion we can have kind of heat addition to the system by virtue of combustion of the charge, that is the working substance of the engine, and then by removing the heat, I mean of course the temperature from the rather extracting heat from the engine cylinder, that is removing some product out of combustion product from the engine cylinder, again we can bring back the piston in its original position, and this process should be continuous, so that I can have a continuous movement of the rather continuous reciprocating movement of the engine cylinder, and a movement of the piston in the engine cylinder, and that reciprocating motion can be converted into the rotary one, and so that our objective will be fulfilled. So, now we will see that what are the different arrangements, what are the different types of cylinder arrangement, so that the idea, that is the charge or fuel air mixture which is being introduced in the during the intake stroke will be ignited, and the entire combustion will be there, and because of this combustion there will be a huge thrust, and that thrust will be acting on the piston face, and piston will have one stroke, and that energy which we are getting from that particular stroke will be stored somewhere, and we can borrow that energy to execute other strokes. If it is 4-stroke engine, that means other 3 strokes, or if it is 2-stroke engine, that is other 1 stroke to execute. So, now we will discuss that what are the different types of cylinder arrangement through which we can execute different processes. Of course, combustion should be there, but there are different types of arrangement to execute all those processes. So, now we will discuss the arrangement of engine cylinder. Arrangement of the engine cylinder. So, our objective was that it is not possible to have huge temperature thermal reservoir that will be connected to the cylinder system, and again it will be taken away from the gas, rather from the engine cylinder, from the working substance of the engine, by connecting it again with the low temperature thermal reservoir. So, this is not a physical solution. So, today we will see that this by through modifying the design, rather by constructing the design of rather constructing the different shapes of the engine cylinder, we can execute all these processes. In fact, this is another important criterion based on which IC engine can be classified. So, I can say that this arrangement, that means arrangement can be, rather I can say engine can be classified according to the position of the piston and this is basically a criterion based on the arrangement of cylinders. So, this is one another important criterion based on which engine can be classified. So, there are different, that is number 1 is which is most common type, and that is known as inline cylinder. Arrangement. Here I can write that cylinder is placed in line. Number 2 is opposed cylinder type. And number 3 is opposed piston type, and number 4 is radial engine. So, that means these are the 4 different classifications which is essentially which are essentially based on the criterion of engine cylinder arrangement of engine cylinders. So, number 1 is the most common type, that is inline cylinder arrangement, where cylinder is placed in line. We will discuss through schematic depiction. Now, number 2 is opposed cylinder type, number 3 is opposed piston type, and finally, we will see that the radial cylinders engine. So, now we will discuss one by one through schematic depiction, that which is which will help us to understand the different functionalities of those engines. So, number 1 is most common type. So, I can write most common type, that is inline arrangement. So, as I said that cylinders are placed in line. So, there are So, we will discuss in one of the in one class that there are multi cylinder engines, I mean engines which are having multiple cylinders, and of course to doubling the power output, in fact to increase the power output we need to connect different cylinders, and that is the multi cylinder engines. Now, when if we talk about multi cylinder engines, of course then heavy vehicles are having multi cylinder multi cylinders engines. Now, when we have multi cylinder, then if we the most common type is the inline arrangement, that is the engines the cylinders are placed in line. Now say this is so all the cylinders pistons in all the cylinders will have movement, but the movement will be restricted between these 2 points, that is TDC and this is BDC. So, this is TDC and this is BDC, and now so this is piston, this is also piston, and this is also piston. So, now we can because so this is connected like this, so the piston will have reciprocating movement like this. So, all the pistons will have reciprocating movement, and the reciprocating movements will be connected to the by the rotary one through this crank and connecting rod. Now what we can see that all the cylinders are placed in line. So, that means cylinders are placed in lines, and all the pistons are connected to the common shaft. Now if we try to have another view, we can I can show schematically that so this is the another view of this kind of engine. So, what we can see that the all these engines, all the pistons are connected to a common crankshaft and supplies power to a common crankshaft. So, this is most common type inline arrangement, that means cylinders are placed in line. Now, next we will see that opposed piston type. So, opposed piston type. It is rather important that I should mention this classifications, I mean based on the types of cylinder arrangement, that means this is when we talk about multi cylinder engines. As I said that many times we need to many times we need to have multiple cylinders essentially to have higher power output from the engine, and when we have multiple cylinders, how we can connect them, I mean there will be we cannot connect them, rather we can connect them through different following different arrangements. So, the first one that was that that is that the all the cylinders are placed in line. Second one is that opposed piston type. Now, through schematic depiction we will see that why we are calling it opposed piston type. So, this is so this is the schematic depiction of the opposed piston type engine. So, what we can see, why you are calling it opposed piston type, because pistons as if they are opposing to each other. Now here we have one common crankshaft and just the output from one engine, I mean, so it supplies power to a common crankshaft. So, we can get just double power output from this kind of arrangement. Number 3 is opposed sorry, this is opposed cylinder type, this is opposed cylinder type, then opposed piston type. So, the first one is opposed cylinder type, as if the cylinders are opposing to each other. Now, we will see that the see the schematic geometrical shape of the opposed piston type engine. So, here we have movement like this, movement like this. So, if it is the spark plug engine, so this is the common spark plug, and if it is not the spark ignition engine, spark plug should not be there, but here this is opposed piston type. So, the pistons are opposing to each other, and the special feature is that both are executing power and exhaust stroke at same time. And two crankshafts are needed, because this is not the case just like this is not the case like inline cylinder type or opposed cylinder type, where we have seen that only one crankshaft is there, but here we need to have two crankshaft, but we can of course get but both are executing power strokes power stroke and exhaust stroke at the same time. So, this is the opposite piston type, because pistons are opposing each other. Both of them, both the engines, both the cylinders will have power stroke and exhaust stroke at the same time, and when they are having power stroke, definitely they will try to oppose, they will try to move away from each other. So, that is that they are opposing. Now, last one is the radial flow engine. So, this is radial type. So, this is the radial type. And so, this part O and A, so this will have kind of movement. So, this is radial type engine, and we will have one common crank. So, this OA is the common crank, and we have of course multiple cylinders which are radially placed, and this is usually, rather I can say mostly, used in aero engines. So, this is the last one, that is the radial type, and these types we can see from the schematic that we have multiple cylinders which are placed radially. If we talk about if the engines are placed along the periphery of a circle, and we have identified this OA is the common crank. So, all the cylinders, all the pistons are connected to the common crank, and this is most suitable for the aero engines. So, what we can say today, we have seen that engine also can be classified based on the cylinder arrangements, and this is an important I can say classification, which is of course for the multi cylinder engines, but on in addition to the classification, I mean which we have seen that based on the types of combustion and number of strokes, this classification which is based on the cylinder arrangement is important, because in most of the cases we need to have multiple cylinder only to have the higher power output. And we have seen that the combustion process, of course we need to have, otherwise we will not get power stroke. So, in case of a 4-stroke engine, we have seen there are only 1 power stroke versus 3 ideal strokes, but in case of a 2-stroke engine only 1 power stroke versus 1 ideal strokes. But I mean whether it is 2-stroke or 4-stroke engine, we need to have combustion, that means fuel charge, that is fuel plus air, or only air which is introduced during intake stroke into the cylinder for SI and CI engine respectively should be ignited. Now, ignition, that we have also discussed that ignition is very an important I can say aspect of the internal combustion engine. Now, that means we need to initiate ignition of the charge of the compressed charge. So, we have seen that spark plug, which is an external agent which is required to ignite, rather to initiate ignition in case of a spark ignition engine, because the compression ratio is not very high for the spark ignition engine. So, the pressure developed or pressure increased at the end of the combustion stroke may not be sufficient to ignite the fuel without this external agent, but in case of the CI engine we have seen that the air which is being introduced during intake stroke is compressed to an extent where the thermodynamic state of the compressed air, rather pressure and temperature, is such that the moment when fuel is injected through the spark plug, the high pressure air and temperature is used to rather is utilized to initiate combustion in SI and CI engine, and we do not record any kind of external agent like spark plug. So, this is essentially classification engine based on the types of ignition, and of course, and then combustion process will be there. So, that is spark ignition and compression ignition, and the number of stroke that we have discussed in detail, and today we have discussed in detail about the classification, which is very important. Again I am telling, because in most of the cases we need to have multiple cylinder to increase the power output from the engine, and if we have multiple cylinder, then whether we will connect the cylinder to a common crank or you need to we need to have different crankshaft, and then the different configuration, different geometrical structure of the cylinder, geometrical configuration of the cylinder we have discussed in detail today. And we will discuss the one small part, that the effect of compression ratio, and that because of the compression ratio for the SI engine is not very high. So, the engine cylinder which need not to be thicker, but in case of a compression ignition engine, since the compression ratio is very high, so engine cylinder should be thicker, and of course to withstand that high pressure, and because of which the CI engines are relatively CI engines are having relatively higher weight. So, that part we will discuss in the next class. So, with this I stop my discussion today, and we will continue in the next class. Thank you.